Okay, today we're going to talk about another transformation called a reflection. Just like looking in the mirror, in a reflection, one of the ways that students remember what to do with a reflection is just like in translations, we circled the SL for the slide. In reflections, we'll circle the FL to remember us that we're going to flip. A reflection is a flip. So a little vocabulary here. A reflection is an image produced by flipping a figure over a fixed point or a line. So you're going to get the mirror image of the point or the figure. So part of our notes, a reflection. To do a reflection, you're going to count from the line of reflection. And this will make more sense as we start working problems. But essentially, when we are flipping over the x-axis, our x values will remain the same and the y values will become the opposite. So we look at that as the ordered pair x comma negative y, because our x coordinates will remain the same but our y coordinates will become the opposite. This looks like this. If I have an arrow over the x-axis, the reflection will be the arrow going in the opposite direction. You can think of it if we were folding the paper in half, one figure would lie on top of the other one. Flipping over the y-axis, the y values remain the same and the x values are the opposite. So we write that as an ordered pair negative x comma y. And what that looks like is we have the y-axis, and if we flip over the y-axis, then we're the equal distance from the y-axis on either side. Now we have some new ones flipping over particular lines. Flipping over the line x equals 4. The line x equals 4 is a vertical line at whatever the x value is. So in this case, it's a vertical line that runs through the point 4, 0. So the first thing you'd have to do is find the line x equals 4, a vertical line at 4. Now we take our figure and we're going to fold it or reflect it over. When you count the figure, you're going to count from the line of reflection, not necessarily the x or y axis. So flipping over the line y equals negative 2, y equals negative 2 is a horizontal line at the y value negative 2. So it's a horizontal line through the point 0, negative 2. So in this case, we're first of all going to plot our line of reflection. We now have our figure and we're going to fold it over. So you see how close this arrow is to the line, the blue line of reflection. So our reflection has to be just as close in the other direction. Okay, so moving on, let's try some examples. It says reflect figure ABC over the x-axis. Now my first piece of advice is to always highlight or mark the axis you're flipping over. Most students who get these questions wrong, it's because they flipped over the wrong direction. So we're going to flip over the x-axis, so I'm going to go ahead and highlight that in blue. And so what are we going to do? How are we going to find our new points? Well, recall what it says is you're going to count the distance from the line of reflection. So this is A is 4 away from our line of reflection. So we're going to go 4 in the other direction to give us our new point A. We're going to do the same thing for our C. 4 away from the line of reflection, so 4 on the opposite side. And our point B, we're going to have to count all the way from point B to the line of reflection, and that's going to be 8. And then we're going to have to count 8 more from the line of reflection, and that will give us our C and our B. Remember, we have our little primes on there, and our little primes on there simply tell us those are the new figures. We can join them together, and we have our new reflected figure, A prime, B prime, C prime. If I'm going to reflect figure ABC over the y-axis, I'm now going to highlight the y-axis, and I'm going to do the same thing. I'm going to take my points, and I'm going to measure 1, 2, 3 away from the line of reflection. So my new C has to be 3 away. My B is 1, 2, 3, 4, 5. So my new B is 5 away from the line of reflection. A is an additional 4 or 7 from the line of reflection. So you're going to have to go 7 to get your A point. So now we have our 3 points, and we can join them together to create our new figure. Remember, the primes tell us that's the new figure. So now we've reflected something over the x-axis and over the y-axis. Now let's just look at our ordered pairs. So our A in our original figure is -7, 4. And in our reflection over the x-axis, it's -7, -4. If you remember the rule, it says if we reflect over the x-axis, our x's remain the same, our x-coordinates remain the same, but our y-coordinates become the opposite. -5, 8 is going to become -5, -8, and -3, 4 is going to become -3, -4. If we recall, over the y-axis, if we reflect our ABC over the y-axis, if you recall, what it said was we were going to turn our x values, we're going to change sign, and our y values would remain the same. So our A is going to go from -7 to +7. Our B is going to go from -5 to +5. And our C is going to go from -3 to +3. So remember the rule, when you're reflecting over the y-axis, your x values change their sign, and the y values remain the same. So let's try a couple more. Now this is a new case in which we are going to reflect ABC over the x-axis. But the problem we have here is that ABC is not in one quadrant or another. It crosses the line, the horizontal axis, x equals 0. Or rather, y equals 0. So we have to first of all count. So let's look and see where this A point is. As soon as I can find my mouse here, here we go. So here's my original A, 1, 2, 3, 4 from the line of reflection, so I am 4 away from the line of reflection. My C is 4 from the line of reflection, so going 4 in the opposite direction will give me my line C. Now my line B is 2 from the line of reflection, so going 2 in the opposite direction gives me my new B. And now when I draw the second figure, I can see that it is a reflection, but it is also an overlap of the two triangles. But finding it is just the same as finding it when it lands in different quadrants. Simply count from the line of reflection to the original point, and then go the opposite direction for your reflected point. So now we're going to reflect ABC, the original ABC, the blue one, over the y-axis. So the first thing you're going to want to do is highlight the y-axis. Okay, so what I've done here before I did the y-axis, at first I went to do the comparison of the ordered pairs between your original ABC and then your prime or your new figures. And if you look at the coordinates for your new figure, you'll see that all of the y coordinates have changed. The x coordinates have remained the same. So now we're going to go ahead and reflect the original triangle ABC over the y-axis. So again, we're going to reflect it by going ahead and highlighting where the axis is, which axis we're flipping over. Once again, we're going to start from our line of reflection and count. C is 2 away, so your new C is 2 away. B, 1, 2, 3, 4, 5. So my new B is going to be 5 away. And my A, you can either count from A all the way to the line of reflection and then count in the opposite direction. Or you can also say how far apart A and C are. And so this is my A. I'm going to put in my new points, join them together, and that is my reflection ABC. You notice your A is on the opposite side from the original one. So you have folded your triangle over. So let's take a look at the comparison of the new coordinates. A, negative 8, negative 4 was the original coordinate, and 8, negative 4 is the new one. So again, in this case, I'm going over the y-axis. My y values remain the same, but my x values change signs. I had a negative 8, I'm now at a positive 8. My B, negative 5, positive 2, has become positive 5, positive 2. And my C, which is negative 2, negative 4, has become positive 2, negative 4. So the rule is that when you reflect over the y-axis, your x values change their sign, and your y values remain the same. So we're going to try 2 more. You may want to pause the video here and try on your own. So the first one we're going to do is we're going to reflect the rectangle ABCD over the y-axis. So I'm first of all going to highlight the y-axis so I remember what I'm flipping over. And then once again, remember, all you're having to do now is count. So my B is 1, 2, 3, 4 from the line of reflection. So it needs to be 4 in the other direction. My A is also 4 from the line of reflection. So my new A needs to be 4 from the line of reflection. Now you've got to remember your C. I'm going to pick up a different color here so you can just see. I'll just pick up the highlighter. This C is 2 from the line of reflection, so I have to go 2 in the opposite direction. The same thing with your D, 2 from the line of reflection and 2 from the line of reflection. So my new A, B, C, and D are these points here, and when I join them together, I get this new rectangle ABCD, but A prime, B prime, C prime, D prime. Again, realizing that they have been folded over so they're mirror images. And the figures overlap because the original figure crossed the y-axis that you were flipping over. So the next one we're going to do is we're going to reflect triangle RST over the x-axis. So in order to flip triangle, I think what I've done here, excuse me, let me just go back here. We're looking at the coordinates A, B, C, D and trying to make that comparison. Alright, if we've reflected over the y-axis, that tells us our x coordinates are going to change sign, but our y coordinates are going to remain the same. And we can verify that by negative 4, 4 became positive 4, 4. Negative 4, 7 becomes positive 4, 7. 2, 7 becomes negative 2, 7. And 2, 4 becomes negative 2, 4. So now we're going to reflect RST. We're going to reflect it over the y-axis. So we're going to highlight the y-axis to go ahead and make sure that we know what we're reflecting over. And then we're going to come and we're going to do the same thing we have been doing. We're simply going to take whatever point we start with, doesn't really matter. There's my new S. My new T is 1, 2, 3, 4. So 4 in the opposite direction takes me to my new T. My new R. The original R is 4 away, so the new R is also 4 away. And there's my new R. I've got my RST. I can join them together to make my new triangle, R prime, S prime, T prime. And now once again we want to look at the coordinates. We have listed the coordinates of the original figure in blue. And now we've gone over the x-axis. So now my y-coordinates are going to change sign. So the -9, -4 becomes -9, +4. The -9, -2 becomes -9, +2. And the -6, -4 becomes -6, +4. So there's only two other cases here, and that's where we reflect over a line other than the x and y axis. Now usually in everything that we've seen, they've actually drawn that for you, but if they didn't, you have to know that the line y = 2 is a vertical line at 2. So the first thing you want to do is you want to draw in, excuse me, I said vertical, is a horizontal line at 2. It's a horizontal line because all of the y values on that line, all of the ordered pairs on that line, the y coordinates are going to be 2. So if I'm going to reflect RST over the line y = 2, I've got the line drawn in. I then have to count from the line of reflection now. So remember, if you're counting S, it's down 2 from the line of reflection. So S prime is 2 from the line of reflection. T is 4 from the line of reflection. So T prime is 4. R is 4. So R prime is 4. We'll go ahead and fill in our dots. Now I'm going to go ahead and remove the lines that I drew. And then I'm going to join them together. And so my reflection of RST, which is R prime, S prime, T prime, is fairly straightforward. Now the line y = 2 makes your change a little tricky, and you have to be a little more careful with your algebra. And the best way to probably handle these is to just go ahead and draw them. So my last one I'm going to do is reflecting figure A over the line x = 3. Now the line x = 3 means that all of the x coordinates on that line are 3. So essentially it's a vertical line at 3. So now I want to reflect over this kind of semicircle with a rectangle attached to it. And what I'm going to do is I'm going to pick some points here, so some reference points, to say, okay, what are some reference points that I can use to graph this figure, because it's not simply a rectangle or a square or something easy, a triangle. So I'm just going to choose a few points, and I've got 5 here. 4 along the, this one should have been here, excuse me, creating this little rectangle, and then of course I now have the semicircle. I've gone the wrong direction here. Here we go. And so now I can join them together. So that's a reflection of x = 3. So I hope that you're not all flipped out, and I hope that it makes it a little bit easier. You need to get started on your in-class assignment, and feel free to watch again as you need to.